All right, so we are so excited for today's presentation. Let's get fired up. Getting started with Firebase Firestore today with Navati Jain. Navati is an iOS developer at Loblaw Digital in Toronto. She's an active volunteer with various initiatives, including Women Who Code Mobile. We are so lucky to have her. NSCoder Toronto, Apple's high school co-op program, and Women TechMakers Ambassador Program. In her spare time, she indulges in writing poems or binge-watching dramedy shows on Netflix. And with that, over to you, Navati.
Thank you so much. I'll just share my screen. Cool, can you guys see my screen?
Yes.
So hey folks, thank you so much for making it today and attending this talk. Today we learn what Firestore is and how you can adopt it in your apps. So let's get fired up. A little bit about me. My name is Navati and I work as an iOS developer at Loblaw Digital in Toronto. And as you can see in this photograph, I am never found without a cup of tea. I'm highly caffeinated. So just a heads up, having some familiarity with Firebase Services helps, but it's not necessary. This is a beginner talk for Firestore, and the query examples are in Swift, but it would look very similar for any other language. Also, I'm not a Firebase or a Firestore expert. I decided to learn Firestore for fun, so let's learn together. So this presentation is divided into two parts. In the first part, we will get introduced to what Firebase is, and we'll do a quick dive into what a relational DB is and how Firestore differs from it. And then we'll have a look at some of the key features of Firestore. The second part of this talk will revolve around creating a Firestore database. And in that process, we will learn some fundamentals of Firestore. So Firebase is a toolkit by Google, and it offers several services to support your app dev journey. Fun fact, Firebase was an independent company and then got acquired by Google in 2014. So what are the services that Firebase offers? Now, when you open the Firebase console, you see this friendly, colorful web page. And on the left panel, you can see a menu of the multiple services that Firebase offers. There are services that help you build your app, like the authentication SDKs. These SDKs help you authenticate your app with providers like Google, Facebook, Twitter, etc. Just like you must have encountered sign-in options with third-party tools like your Gmail account or Facebook in some of the apps that you use. Then there's also Firestore database, and that's what we're going to learn today. You can also see there's another database, Realtime database. So these are the two database services that Firebase offers. Realtime database was the initial database that Firebase offered, and there are some differences between these two, and we will be reviewing them shortly. There are other services as well, like storage, where users can store content like photographs and videos. Firebase offers hosting services as well. And then there are cloud functions so that you can use all the server functionality without worrying about other server stuff. Firebase also offers machine learning services. Plus, Firebase is pretty popular for several release and monitoring services like Crashalytics for managing your crash reports and logs, Performance for performance monitoring metrics, and then there is Test Lab so that you can test your app on various devices on the cloud. They also offer services for app distribution. And the list doesn't end here. There are several cool analytics services like Google Analytics and engagement services like A/B testing, remote config, app messaging, and so much more. So in a nutshell, Firebase has a lot to offer. So let's review some database concepts. A relational database is very structured. It is schema-based, and I'll get into what a schema is in just a bit. Here, the database is implemented as tables. Now, NoSQL, on the other hand, is a non-relational database. It can be a document DB or a key value DB or a graph-based DB, and we'll discuss what those are. But do note that both the database services that we saw in Firebase's suite, that is real-time database as well as Firestore, they both are NoSQL database. Now, some of you might be familiar with relational database, and this might sound really basic, but let's have a quick refresher. One way to think about a relational database is to consider a spreadsheet. It's a table, right? More importantly, it's a structured table. That is, there is a schema, which means that there is an outline that describes how your database is organized, like what the columns are going to look like, which column will serve as the primary key, and what the relationships between these tables would look like. So let's consider an example. Here's a list of my favorite TV shows. And by no means is this a complete list, because if you were to put all my favorite TV shows, it would not fit in one slide. Anyways, if you look at this table, you can see the title of the series. You can also have the number of seasons, maybe some more columns for the genre, the description. And if I need to uniquely identify each row, I would need a primary key. In this case, we can use the series ID, that is the first column, as the primary key. We can also have some constraints or restrictions, like the title should always be a string, the title should always be of a certain length, and we don't want it to be null. Similarly, the number of seasons should always be an integer. So in this way, we have a schema established. Let's say we have another table for the episodes of these TV series. And here we can have the title, the episode length, maybe also the release date and the director of that episode. So let's use episode ID as the primary key. Now, to create a relationship between these two tables, we would use a concept called foreign keys. So in this case, we'll use the series ID as the foreign key. Think of it as a borrowed column from the parent table. So if I want to find out which series does the first episode belong to, then I would look at the foreign key, that is a series ID, and I can see it's S123. So I can match that with the first row here because it has the same primary key S123. And the same goes for the next row because that also matches with S123. And so we have created a relationship between these two tables with the help of the foreign key. Similarly, if you look at the next episode, we can match that to Gilmore Girls because it has the series ID S124, and then for the next episode as well. So the query language that we use for a relational database is SQL, which stands for Structured Query Language. Now, a challenge with relational database is that it gets really hard to scale with all these constraints and relationships, and it gets very resource intensive. So to deal with demands, you would typically scale this vertically, which means that you are trying to improve the processing power of your host machine. NoSQL, on the other hand, doesn't have this rigorous schema-based approach with all these constraints and formatting rules. So scaling is much easier. It can be scaled with a horizontally scaling approach, which means that you distribute the database across several machines. The focus here is on speeding up the queries and making it flexible to add more fields. So you can implement NoSQL as a key value based approach where you have a hash key and a value. And an example of this could be Redis. There's also the white column based approach. So here, not all rows need to have the same columns. Cassandra is one such database. Then there is the graph-based approach where entities are nodes with static relationships, just like in social networks. Neo4j has this approach. And finally, we have the document-based implementation where there's a JSON-like document. MongoDB is an example, and so is Firestore. So let's compare relational database versus NoSQL DB. So relational database is table-based. It's schema-oriented and structure really matters, just like we saw in this TV series example. NoSQL is a non-tabular approach, and the structure is more flexible. You can implement it in different ways, like we just saw in the last slide. So relational database is good when you need your queries to be more customizable and you're not sure of what kind of queries you would need, or you just need more options. Because with relational database, you can run more queries, like you can join queries, or you can use the where clause, and you can match different string patterns. NoSQL, on the other hand, is applicable for situations where your access pattern is known. That is, you know what kind of queries you would like to run. The benefit here is better performance and lower latency. Also, as we discussed, in relational database, it typically scales vertically, whereas with NoSQL database, it scales horizontally. So think of this as in an apartment building. For relational database, if you were to consider an apartment building, you can stack floors, you can go up. Whereas in NoSQL, if you wanted to scale horizontally, then you would add new houses in the neighborhood, like this. So the beauty of Firestore is that I can leverage Google Cloud Services because they take care of all that backend stuff like scaling and setting up servers. Plus I have the advantages of Firestore, which is a robust client library. They offer security rules for access. It is near real time. And with a multi-regional data replication, you can have a strong reliability. Plus it is pretty easy to set up. And they also offer offline support, transactions, pagination, and so much more. So with Firestore, I have these advantages of the cloud, and I can create apps that sync. I can have my users collaborate with other users, and I can have the app run on multiple devices, like on the iPhone and on an iPad, on an Android device. So basically, I can have my cake and eat it too. So let's examine some of the key features of Firestore. Firestore is a document-based database, and the documents have a JSON-like structure. That is, there are keys and values. Key for the field name and value for the value that it holds. So for example, the name could be the field, the name can be the key, and the value is Kelly. Or you can have age as your key and the value is the number 15. Or you can even have address as a key and the value is this nested JSON. So the documents in Firestore are JSON-like, but that's not all. The structure of Firestore is a collection of documents. So think of a folder with many files. At the root, you need to have at least one such collection, which has several documents inside it. Also, Firestore supports a hierarchical structure. That means a document can point to its own collection. And if this sounds confusing and you're like, what? Hang on, let's look at an example. So let's say we're back in school. Consider these students. There's a student called Kelly and another student called Raj. And we have a document on each of these students. We can have some basic information like their name, their address, their major. And at the very root of our collection, at the very root of our database is this collection of students. I'm going to maintain this color scheme So I'm going to maintain collections as the yellow color and documents with pink. Let's go with that. Now, they're students, so they are obviously enrolled in some courses. Like Kelly might be enrolled in that dreaded algorithm course, and she might be enrolled in C++ as well. And so in this way, Kelly's document has its own sub-collection of various course documents. In each course, we can have the course name, the course code, the professor who's teaching that course. Similarly, Raj can also be enrolled in some courses, and his document can have a reference to a sub-collection of courses. And as you can see, we've started to build a hierarchical structure. So for Kelly's course, she would be handing in assignments for the course. So maybe she has a couple of assignments for the algorithm course, and now we can have a document on each of these assignments, and the algorithm course can have its own sub-collection of these submissions. Similarly, we can have sub-collections for the other course documents as well. So as you can see, the database is pretty hierarchical. Hopefully with this, you're getting some idea of what Firestore's database looks like. Now, it's not necessary that you have only one collection at the root. You can have multiple collections at the root, but you definitely need at least one collection. So let's consider the university example. The first collection could be for the students, like we just saw, and maybe we can keep the second collection at this root for the faculty members, right? Another thing to note is that a document is not restricted to having only one sub-collection. You can have multiple sub-collections as well. So if this was a faculty collection, then each faculty's document could point to maybe the courses that they teach, the research projects that they're working on, and another collection could be for their employee information. So you can start to see that Firestore's database is pretty flexible, right? Now, when you retrieve a document in Firestore, you are retrieving that entire document. You cannot retrieve a document in part. So if you want to retrieve Kelly's grades and you don't want her other information like her address or her major, you don't have that choice. You have to receive the entire document. So keep that in mind when you're planning your database. Also, another thing to note is that the Firestore document is limited to the size of 1 MB and 20,000 fields. Also, the billing is based on the number of reads and writes that you do in Firestore. So let's talk about queries. Queries in Firestore are shallow. Not like Lady Gaga's shallow, but like this. So let's say you want to run a query and fetch Kelly's information. So when you try running a query on Kelly, then all you're going to get is Kelly's document and none of the sub-collections. So that's why it's shallow. So that's all you're going to get. You're just going to get Kelly's document. Also, as we discussed just now, you will get the entire document. You cannot choose to get a few fragments of this document. Also, as we discussed, Firestore is a NoSQL database and it is schemaless. It isn't as rigid and structured as a relational database. And being schemaless has its advantages. It is flexible, so you can easily add new fields. So let's say in the student database, if you wanted to add some more information about their work experience, you can easily add those fields. So this is good because it supports an iterative approach. Next, Firestore has the power of security rules. Security rules help you control the access so that you can create rules around who can access which document or which collection. And this is good because if Raj was trying to be snoopy and find out Kelly's grades, you can stop him with security rules, right? Also, you can use security rules for enforcing validation. So for example, if you consider grades could be a percentage and you want to ensure that they are numbers between 0 to 100. So you can use security rules to enforce that it's always going to be a number between 0 to 100. And that way, even if your students are super brilliant, you won't be allowed to give them 200. So this is beyond the scope of this talk, but I wanted to mention security rules because they are pretty important. So now let's compare real-time database versus Firestore, the two database services that are offered by Firebase. So real-time database is a simple JSON tree, like in the screenshot. But in Firestore, we know that it is a collection of documents. So if your data is simpler and it's not too nested, then you can manage with real-time database. Here, the data would be denormalized, meaning it would be more flat. But if you have more complex data, then Firestore would be a better choice. Also, real-time database has an extremely high uptime guarantee. Firestore's guarantee is good as well, but for critical stuff, real-time database would be more reliable. And in real-time database, the queries are deep by default, and you can access granular data. Whereas in Firestore, as you know, the queries are shallow, and you will be given an entire document. Also, Firestore can support richer queries with advanced sorting and transactions compared to real-time database. So let's cool down that fire. And if you have any questions before I proceed with the next part, let's discuss.
A couple questions out of the chat. Are relational databases considered old school now? And does the fact that I've worked with relational databases make me old school? Drop your best opinion on us.
No, I don't think it's old school at all. It's still very relevant because it depends on the needs that you have for your application. There are still a lot of cloud services that offer a relational database as a service, and it is pretty good for complex queries because you have a lot of flexibility. SQL is pretty amazing. You can run a lot of queries. You can do joins on pretty much anything. You can do pattern matching if you want to have a string match with a certain pattern. That's also easy. So in no ways is it old school, because it is still quite relevant. It's just that with the NoSQL DB, you have more flexibility. We know that we know that relational database is pretty rigid that way. Like adding a new column can be pretty painful when you need to know your structure well in advance. So yeah, I think both are relevant. You just need to figure out what your app needs.
Great answer. I also just want to call out, you're getting so much love in the chat for both your beautiful slides and great use of imagery. But one other question that popped up is, do you have any tips on a good place with good visuals to relearn databases? So any specific resources you might have used to put together your excellent visuals for this presentation?
To learn on
yeah.
To learn Firestore in general? Is that the question?
To learn databases in general.
To learn database, like relational or non-relational? No, NoSQL rather. I mean, like, so like if you're completely new to database in general, I think W3 Schools is a very good resource to figure out different types of SQL queries. Like it's their website. I mean, at least back in the day, I remember like that really helped. And I know like I was few years back, I was pretty confused about things like normalization, the normalization concepts in SQL. So I remember lynda.com, which is now LinkedIn Learning. They had really good resources. So that's another place that I would point you to if you're trying to understand that. But for learning NoSQL, I primarily used the official documentation on Firestore. Their videos are nice. You just might need to run it on a slower speed. They do speak very fast, and and there are some resources that I'll mention at the end. There are some nice videos in there to explain some of these key concepts on NoSQL and even relational database. So yeah, I hope that helps.
And then the last question that has popped up is, what are the practical uses of Firestore? How secure is it? And can it be used to store personal information?
Firestore definitely can be used for like any NoSQL need. There are other competitors as well. There's MongoDB, which is also quite popular. But the learning curve with Firestore, I haven't used MongoDB, but I've heard that Firestore is like much easier to use. Their UI interface also makes it pretty easy. Running queries is also pretty nice. Like it's their API is pretty good. In terms of security, they have security rules. This is a Firebase service in general, so you can, that really helps. Like you can enforce security with that. So yeah, I would encourage you to go with Firestore database and give it a try.
Awesome, excellent answers. I think that's all the questions that we have so far. And then also just for everyone in our audience, feel free to keep dropping those in, and I pull them out so that we'll have some more time at the end to ask those as well.
Okay, so let's continue. So yeah, move on with part 2. So I love learning outside of work, whether it's through attending events such as meetups and conferences. You guys are here, so I'm guessing you guys like doing that as well. Also building my portfolio through projects, or learning through books and courses. And also when we are in events like this, we get to network a bit. Maybe in this case, it's more through the chat. Now, all of this tends to overwhelm me, and I end up looking like this. So I thought, maybe I could make a simple app to keep track of all these activities. So we'll explore what the database would look like to support this kind of an app. So some of the concepts that I'd like to cover when we go through this is collection of documents, some of the simple fields, arrays, indexing, also maps, and sub-collection and top-level approach. Some of these things may have started to make some sense, but if not, that's fine. We'll be going through each of these concepts. So we talked about how Firestore is a collection of documents. So in my, if I'm engaged in several activities, maybe I attended a meetup on Swift UI and a workshop on blockchain, and I enrolled in a course and I read a book on SQL. So I can have a document representing each of these activities. And my Firestore structure would be a collection of these documents. So let's have a look at each of these documents. So we'll look at some of the simple fields. Let's consider this activity. I can have fields like the name, the type of activity, whether it was a meetup or conference, a course or a book, and other relevant information like the organizer, or if it's a course, I could write, I could track the instructor's name. If it's a book, I could keep track of the author or the publisher. So in this case, all of these fields are strings. And I can also have a field on the rating. So I could store that as a number so that I know how much I actually really enjoyed that activity. And we can use security rules to enforce this number to be a number between 1 to 10, right? Now, if I want to run a simple query and find out how many of my events were a meetup, then I can run it like this. So first I would create a Firestore reference, and then I would create a reference to the collection, because at the very root you have a collection, and in this case our collection is activities. So I have a variable pointing to that. And now inside this collection, I would like to know how many of my documents were of type meetup. So I would say activities collection dot where field, the activity type is equal to meetup. So that looks straightforward, hopefully. And let's say I want to find out how many events did I really enjoy. So maybe I can find out the rating to be greater than 7 and consider that as something I enjoyed. So I would use the where field again, and I would say rating is greater than 7, like this, right? Now, when it comes to queries, you can, there are 2 ways to run your queries. You can either run them just one time so that you can find out how your database looks at that point of time. So this is how you could run your code snippet. You can use get documents. And like here we have the same identical query from before. We have activities collection dot where field, and we have rating greater than 7. And now I have this get documents function. Basically, this will have a callback, and you can you get 2 things from that callback. You get the snapshot so that you know what your database looks like at that point of time, as well as an error field. And inside this snapshot, you can then get all the documents inside that collection. And inside each document, you have your key and value, right? So that's how you would go about a one-time approach to running your queries. The other approach is using a listener. So with a listener, you can find out if there were any changes in your database. So every time your database changes, the logic would get triggered. So this is how your code would look for a listener, and examine the 2 different code snippets and try and find out what are the differences between these code snippets. So can you see the difference? The difference is just this function. So you would use get documents for one time, and here you would use, you would add a snapshot listener. So it's pretty simple. Okay, so now let's talk about arrays. Now, every time I go for some activity, I would probably be reinforcing different skills. Like in this Swift UI meetup, I got to learn a little bit of iOS, Swift, and some UI concepts as well. So I can track these skills as different tags or different keywords like this. And I've saved it as an array. Now, if I want to run a query and find out how many, in how many of these activities did I learn some iOS or Swift, I can use the array contains query. Okay, so let's just look at what Firestore would look like in the console. Can you guys see my screen?
Yes, we can.
Okay, great. So yeah, so this is the Firestore console. And in here, you can see inside the data tab, you can see activities. Activities is my collection at the very root. And inside this collection, we have various documents. It always alternates between collections and then documents. And documents can have their fields as well as collections. So let's click on one of these documents. So if I open this document, I can see a few fields. Similarly for the other documents as well. And I can create a new document right here, or I can do that programmatically through their API. Similarly, in each document, I could have another collection. If I were to create another collection, then I would, it would come in here. So that's how you would navigate, and like you have this nice UI interface to look at your Firestore database. Okay, so let's talk about index. So an index is a data structure that is a sorted list of all the values of your database. So it has the values as well as the location of the element. So think about those books that you used back in school, all those textbooks. If you look at the very end of your book, there are a few pages for the index, right? And in that, in the index section, you will notice that there are various terms in there, and they are in an alphabetical order. So the fact that it's in an alphabetical order is that it is sorted, right? So there is a sorted list of all these terms, and in each term, for each term, you would find the page numbers, right? So for example, the word algorithm could be on page 91 and 254. So now you know that if I want to look up this concept, I just need to go to either of these pages instead of scanning the entire book and looking for where the word algorithm was mentioned. So you save so much time. Similarly, in Firestore, it creates an index for all the fields automatically. And if you want that it shouldn't create an index for any of your fields, you can tell Firestore to create an exception. So thanks to auto indexing, we can retrieve our data with simple queries like this query. So things are sorted for us. And what happens behind the scenes is that Firestore is using a sophisticated binary search algorithm and searching through this index and retrieving whatever documents you need. And this means that, yes, when you are doing a write to Firestore, there is more data being stored, but that helps you with the reads. The reads are much faster, and that is the priority in Firestore. The reads over writes priority. So this is one query that could easily be run because there is an index created for you on the activity type. Similarly, we saw for this field rating, there's an index created for you. So Firestore knows where to go and find things. And also, if you want to combine equality operators like this, Firestore can do that as well. So if you want to find out how many of my activities were meetups organized by women who code, then you can do that. And what Firestore would do is that it would look at the index for each of these fields and intersect them. Now, if I want to combine an equality operator and a range operator, like I want to find out how many of my activities were meetups and their rating was greater than 7. So for this scenario, Firestore cannot use its auto-indexing feature to figure that out because it won't be able to intersect these two kind of indexes. So you would need to use a composite index. A composite index is also a data structure of your records, but here the sorting is done based on the concatenation of multiple fields. So in this case, it would be a combination of activity type and rating. And here Firestore is not going to automatically create all these indexes for you beforehand, because think about it, even for a handful number of fields, Firestore cannot sit and create all those combinations of all the fields. That would be way too many combinations. It's impossible, right? So if you think you're going to need, you're going to run such a query, then you can let Firestore know and create this composite index. And the good thing is that it's not complicated to create a composite index. You just run this query one time in your app, and Firestore will generate a link for you. You just click on that link and it's done. It's generated for you. Keep in mind that there is a limit to how many indexes you can create like this. There's a limit of 200 such indexes. Now let's talk about maps. So when I attend an event, I like making some notes, and I can probably store this information as a write-up, and I could store it as a long string. That's one way to go about it. Another way I could store this information is by keeping it as a nested JSON. That is, I can store associated fields like the text as well as the date. And if I posted this write-up on some social media platform like Twitter, then I can keep track of that as well. So this kind of nested JSON is called a map in Firestore. You could also have multiple write-ups, and in that case, you would use an array for this. And one thing to keep in mind, like we discussed, when you retrieve a document in Firestore, you're fetching all of it, right? You cannot fetch a partial document. So if you have this write-up information, and especially if it's an array, then you might have a lot of data that you're retrieving when you run your query. And if you have an app where there is a table view with all your rows and all your rows are displaying all the activities that you have been to, you might not want to show them the write-up in the row itself. Maybe that's something you want to show on the details view, right? So consider this as well when you're designing your DB. Now let's talk about sub-collections. So another way to deal with this write-up scenario is that you could store them as sub-collections of various documents. So I can have one document for my LinkedIn write-up, one for Twitter. Twitter, after all, has like 280 characters, so you probably have a shorter write-up. Maybe one for Instagram. And now we have a sub-collection of write-ups. That is what a sub-collection would look like. Now, if I want to run a query and find out how many activities did I post about on Twitter. So let's say we have this structure. So I have my documents have their own sub-collection of write-ups, and all those write-ups might be on different platforms, right? So if I want to run a query to find out how many did I tweet about, I can run a query like this. So the thing is, we are asking Firestore to search through all the sub-collections of different documents. So Firestore will have to pretend as though all these sub-collections are like one collection. To do that, you need to create a collection group. So that's what we're doing in the first line. We are creating a collection group of write-ups, and then you can use your regular where clause and say, okay, I want to find events that were posted on Twitter. And now one more concept before we wrap up. Let's talk about top-level approach. So think about these conferences that you go to. What do you like about these conferences? Like for me, I like the food that we get, the free food, to learn something, and yes, also to meet new people. So when you meet new people, you might want to track some information about those connections that you made, so you can remember them and keep in touch. So let's track this in our Firestore. So one way to create documents on each of our contacts is to have a sub-collection, right? Like we just did for the write-ups. Maybe I can have a document on each of them and maintain information about where I met them and where they work and what their designation is. So there is, this is one way to go about it, right? Another way is that we could have a top-level collection. So this is my current structure. I have my different activities in its own collection. Each of these activities point to their own sub-collections of write-ups. And I can keep my connections in a separate top-level collection, because we are allowed to, of course, have more than one collection, right? So I've maintained my connections in another collection. And this kind of approach might be good if you plan to run queries that are independent of your activities. Maybe you just want to generally look at all the contacts that you have and say, oh yeah, how many of them work at so-and-so company? So you can decide between these two approaches, a sub-collection approach or a top-level collection, based on what kind of queries you plan to run. And also, I could proceed and have more sub-collections for each of these connections. Maybe their contact info could be a separate document. So yeah, wrapping up, these are some of the references that I used. And like I said, I primarily used Google's content. And yeah, we covered concepts on what Firebase is. We looked at how SQL DB would differ from a NoSQL DB, and we saw some of the key features of Firestore and how it's a collection of documents. And we built a Firestore database together. So thank you so much.
Awesome presentation. I just want to reiterate what's in the comments is that was a fantastic presentation with fantastic graphics, and you explained all of those concepts so well with such concrete examples that made it really easy to visualize the usages and the concepts. There were a couple questions that popped up, and so we'll dive into those. And if anyone has any other questions, feel free to drop those in the chat while we get the ball rolling. First question, are Firebase Realtime Database and Firebase Firestore both NoSQL? Can both be used together in your application?
That's a good question. Yeah, they both are NoSQL. And you can definitely, I believe you should definitely be able to use both of them in the same app. It's just that they would be different databases. They would not communicate with each other.
Sure. That makes sense. There were a couple questions about the combination composition indexes, those two indexes that you showed. Are there conditional, sorry, are where conditionals additives only, or can you also do or combinations?
That's a really good question. So yeah, with if you want to do an or, like, you can definitely chain your where clause if it's like an equality operator, or if you want, you can even use like a range operator, that greater than kind of operator, so long as it's the same field. If they are different fields, then you would have to use you'll have to use a composite index. And for or, you cannot do that in Firestore. You would have to run them as two different queries, and then in your client side, you can combine it.
Sure, that makes sense. Okay, and then a follow-up to that is a composite index where, like, so a composite index is like a combined query using and in relational databases.
It's like a combine and I'm trying to figure what that means. What do you mean by combine and? Actually, I need to clarify that.
So using the composite index is like creating a query in a relational database where you use and, so that additive property.
Oh, so again, the thing with composite index is, so if you want to do an and query, it's like doing, it's like chaining the where clauses, right? And again, for that, if it depends on what kind of query you're running. If you're, like I said, if you're running multiple equal tos, like you're trying to find out where my meetup was, where my event was a meetup and run by women who code, and rating was equal to 10, like I'm trying to chain various things, then if they're all equal to type of operators, then you can definitely just run that without even a composite index. Composite index comes in because Firestore cannot, just simply consult its in regular index, a single index on its own. It needs a little help. So if you plan to use two fields, which cannot be easily intersected, then that's when you need to use a composite index. So again, if you use like a range operator, like if I want to find out the event that's a conference and its rating is greater than 7, there's no way for Firestore to combine this to intersect it on its own. So you would help Firestore by creating an index so that it can concatenate these two fields And based on that, it already has that indexing done for it. It's much easier for Firestore to now look up the exact query that you're looking for. So I hope that answers that.
I think that it does. Excellent answers. Okay, and then the last question that we had in the chat is, from the Firebase dashboard, is it possible for us to see user created data?
Yeah, you can see the data. Like we just saw in our database. You can go and look at the data.
Awesome. I want to call out this comment. This is my first Women Who Code talk, and I loved it. Super useful. Thank you so much for such an amazing talk. And I just want to reiterate that incredible discussion here.
Thank you so much.
Any other last minute questions before we wrap up our event today? I'll give you all just a couple of minutes to decide. I just want to thank Navati so much for being here and everyone who joined our event today. Again, we have some upcoming events that you can find on our website, womenwhocode.com/mobile, and we would love for you to come to those. Consider presenting at one of our events, or consider submitting a CFP to our Connect conference. And for Deepa, yes, this session was recorded and should be available on YouTube in the next couple of business days. It is Friday, so it'll be a couple more days than usual, but a very quick turnaround time there. All right. Well, again, thank you all so much for being here. Navati, excellent presentation. Can't wait to post it online for more people to come back and see it. Really excellent slides. I'm not surprised, but blown away. Such a professional and beautiful presentation. Thank you all so much for being here, and we hope to see you at the next one.
Thank